Coaxial, the durable shield, understanding coaxial cabling. In the world of networking and telecommunications, coaxial cable, or COAX, stands out as a unique and incredibly durable veteran. While it is most famously known for bringing cable television into our homes, it remains a critical component of modern high-speed internet delivery through cable modems and is widely used in specialized fields like satellite communications and security camera systems. The anatomy of a coaxial cable. The name coaxial comes from the fact that all of the cable's components share the same axis. Unlike the twisted pair cables we discussed earlier, which use 8 separate wires, a coaxial cable relies on a single, central core to carry the signal. This design is focused on one thing: protection against outside interference. The center conductor. At the very heart of the cable is a solid or stranded copper wire. This is the lane where the actual data or video signal travels in the form of electrical pulses. Because it is a single, thick conductor, it can carry high-frequency signals much more efficiently than thin, twisted wires. The dielectric insulator. Surrounding the center conductor is a thick layer of plastic or foam insulation. This layer acts as a spacer, keeping the center conductor exactly in the middle of the cable. If the center wire gets too close to the outer layers, the signal will leak or degrade, so this spacer is vital for maintaining the cable's performance. The metallic shield. This is the secret weapon of coaxial cabling. Wrapped around the insulator is a layer of braided metal wire or foil. This shield acts as a Faraday cage, catching any outside electrical noise or radio interference and draining it away before it can touch the center conductor. This is why you can run a coaxial cable through walls filled with power lines and still get a crystal-clear television picture. The shield provides almost total immunity to external noise. The outer jacket. Finally, the entire assembly is wrapped in a tough plastic jacket. Because coaxial cable is often used for outdoor installations, such as running a line from a utility pole to a house, this jacket is designed to withstand sunlight, rain, and extreme temperature changes. Common types: RG6 versus RG59. Not all coaxial cables are the same. Technicians typically choose between 2 main radio guide or RG ratings based on the job at hand. RG6, the modern standard. This is the cable you will find in almost every modern home. It has a thicker center conductor and much better shielding than older types. This allows it to carry high-bandwidth signals, like high-definition video and high-speed internet, over long distances without losing strength. It is the mandatory choice for satellite dishes and cable internet modems. RG59, the legacy choice. This is a thinner, more flexible cable. While it was once the standard for televisions in the 1980s and 90s, it cannot handle the high-frequency demands of modern 4K video or gigabit internet. Today, it is mostly used for short distances in closed-circuit television, CCTV systems, or for connecting older VCRs and game consoles. The connectors, F-type and BNC. To plug these cables into a device, a technician must use a specific connector. These connectors are designed to maintain that shielded protection all the way to the plug. The F-type connector. This is the most common coaxial connector. It features a threaded nut that you screw onto the back of a television or cable modem. It is unique because it doesn't have its own pin. Instead, the solid copper center conductor of the cable sticks out through the middle of the connector to become the pin itself. This creates a very clean signal path with very little loss. The BNC connector. The Bayonet-Nielsen-Selman, or BNC connector, is a specialized plug used in professional environments. Instead of screwing on, it uses a push-and-turn locking mechanism. It is favored by technicians in professional video production and networking because it provides a very secure, vibration-proof connection that won't accidentally come loose. Why use coaxial today? You might wonder why we still use coax when we have fiber and high-speed copper. The answer is infrastructure. There are millions of miles of coaxial cable already buried in the ground and built into the walls of homes across the world. Through a technology called DOCSIS, Data over Cable Service Interface Specification, Internet providers can send massive amounts of data through these existing copper lines. This allows them to offer gigabit speeds to customers without having to dig up every street to lay new fiber. Coaxial cable remains the final mile bridge that connects the high-speed fiber backbone of the internet to the router in your living room. By understanding the protective layers of the coaxial design and choosing the right RG rating for the task, a technician can ensure that data stays CL. And stable even in the most electrically noisy environments.